Hey guys, welcome back to my channel. In this video, we'll be doing questions 8 and 9 from class 12 HSC's exercise 2.1 chapter 2 application of derivatives from the book Mathematics and Statistics part 2. So basically this question deals with surface area of a sphere. So you have a spherical soap bubble that is expanding and you're given the rate of the increase of the radius. Now to find the rate of increase or decrease of anything, you have to find its derivative. So the radius is increasing at this rate, and at what rate will the surface area increase if its radius is this much, correct? So what you're given is that dr by dt is this much and your r is this much. You know this formula that the surface area of a sphere is 4 pi r square. So first what we'll do is to get the terms ds by dt and dr by dt, we'll differentiate this with respect to time. So you have ds by dt is equal to, now 4 pi is a constant, take that out, and differentiating r with respect to t, you get 2r into dr by dt. You have the value of r and you have the value of dr by dt, which is this much and this much. So what you will do is ds by dt is equal to 4 pi into 2 into 5 centimeter into your dr by dt is 2 by 100 centimeter per second, correct? So now what we'll do is cut this off. 5 2s are 10 and that gives you 8 pi by 10 centimeter square per second, centimeter per second, and that's what you get. Yeah, so you have 0.8 pi centimeter square per second. Since is the surface area, it will be in square, and 0.8 because 8 by 10, instead of putting it in the terms of fraction, you will use a decimal number. So 0.8 centimeter square per second. What do? You get a formula, you differentiate the formula, you substitute the terms known to you, and then finally get the answer by substituting everything that is given. So moving on to question number 9, we have the surface area of a spherical balloon is increasing at the rate of 2 centimeter square per second. At what rate does the volume of the balloon is the volume of the balloon increasing when the radius of the balloon is 6 centimeters? So we have ds by dt is equal to 2 centimeter square per second, and we also have that radius of the balloon, that is r, is equal to 6 centimeter. You have to find dv by dt. So we have from ds by dt we can find dr by dt. So we know that s equals 4 pi r square from the previous question, and we know that v equals 4 by 3 pi r cube. So first we'll differentiate this. You have ds equal to 4 pi 2r into dr by dt. So what we'll do now is we'll substitute everything that we know. We know ds, okay, ds by dt. We know ds by dt to be 2. So 2 is equal to 8 pi. You know that r is 6. 8 pi into 6 into dr by dt. So dr by dt is equal to 2 by 48 pi or 1 by 24 pi. Now we'll differentiate v equal to 4 by 3 pi r cube. So you get dv by dt, that is the term that you have to find, is equal to 4 by 3 pi into 3r square into dr by dt. So you have 4 by 3 into pi into 3 into r square is 6 square, that is 36, and dr by dt is 1 by 24 pi. Cancel off the pi, 3 cancels, and 4 6 are 24, 6 6 are 36. So you have dv by dt is equal to 6 centimeter cube per second. And that's the answer for this question. So guys, that's it for the video. Don't forget to like, share and subscribe, and comment down below if you have any more queries or suggestions. And thanks for watching.